So we are going to do the very next problem. That is very next problem is equal to, that is your x of n is equal to what? That is minus u of minus n minus 1. So that is your plus, that is what I can say, I'll scroll it. So that is plus your half to the power of n into u of n, right? It is your half I'm sorry, it is your half to the power of n into u of n, right? Yes, it is your half to the power of n into u of n. And so therefore now we are going to start solving the problem. So here you know that what is your u of, that is minus n minus 1. You know what is that? We have already done in the last section, so I'm going to write that now. So see, what is your u of minus n minus 1? You know that in your last classes. So before that, let me take my x of z formula, which is, we have to start by that formula itself. So therefore that is n is equal to minus infinity to infinity. What I can say, that is your x of n into z to the power of minus n. That is what you are going to do. And the next thing what you are supposed to do is, you are going to substitute the given x of n to the particular expression, this expression x of z formula. So therefore you are going to get it as, that is put a bracket, that is minus u of, what I can say, minus n minus 1, and that is plus, that is half to the power of n into u of n, that is n into u of n, that is your u of n, that is a whole to the power of, I'm sorry, just a second, that is half to the power of n into u of n, that is whole to the power of whole into, that is what I can say, here z to the power of minus n, right? So now coming on to my next process, just a second, I'm sorry. Coming on to my next process, what I have to do is, I have to separate the summations for this particular as well as this particular, and what I have to do is, I have to multiply with z to the power of minus n. So what I have to do, I need to take, this is summation of, what I can say, the n is equal to minus infinity to infinity, that is what I can say here, minus u of minus n minus 1 into z to the power of minus n. So plus what? So plus it is what I can say, the half to the power of n. So that is summation of n is equal to minus infinity to infinity, what I can say, that is your half to the power of n into half to the power of n into u of n, that is u of n into z to the power of minus n. So this is what is I have to do. So we, these kinds of procedures we have already done, right? We have already done in last section, so you can see through that. And now coming on to my next procedure, so that is, I need to get my summation, proper summation. So for u of minus n minus 1, the signal starts from, that is n is equal to minus 1 to n is equal to, that is what I can say, the minus infinity. So that is why I get it as minus z to the power of minus n. So that is plus, so this minus is what I've got it from here. I have inherited this minus from here, right? Once again I take, that is n is equal to, what I can say, the 0 to infinity, that is what your 1 by 2 to the power of n. Why 0 to infinity? Because your u of n signal starts from what? That is your u of n signal starts from, that is n is equal to 0 to infinity. So this is half to the power of n into z to the power of minus n. Yes. So now what are you going to do as? So you are going to just remove the subtraction symbol outside. So if I remove subtraction outside, I get, so that is minus of n is equal to, what I can say, that is 1 to infinity. What is this 1 to infinity? We have discussed in the last problem. That is what, if you shift this 1 to downward and minus infinity to upward, that is changing of the limits. So what I can say, this will become my inverse. So that is why I get z to the power of n, that is plus summation of n is equal to 0 to infinity. What I can say, that is 1 by 2 to the power of n into z to the power of minus n. Right, you know these kinds of things, right? I need not to tell it because I've already done these procedures in the last problems itself. So you can go to that problem so that you can follow the same procedure over here, right? Yes, so now coming on to my next one, what is that I have to do is, so next I have to apply the formula. So here, as your n is equal to 1, so the formula is alpha to the power of n only, but your n becomes equal to 1, right? So for that my formula would be what? That is what I can say, the minus z divided by, that is 1 minus z. I get the formula, that is plus what I can say, that is 1 divided by 1 minus 1 by 2, that is z inverse, right? 1 minus 1 by 2, that is your z inverse, right? This is what is the formula for this particular. You got it right? Yes. So now next what I have to do is, I have to convert, as this is in the form of z, I have to convert it into z inverse. I want like this. So that is why I'll take it as, that is what I can say, the z, if this is what I get it as, that is 1 divided by, that is z in 1 minus z inverse. I'm really sorry for it. It is 1 minus z inverse. So that is plus, so I get it as 1 minus 1 by 2, that is z inverse, right? So now for my term to convert, so I need the term to be lesser than 1, right? So therefore what I have to do, so if I consider, what I can say, this particular one if I consider, that is this equation, so here this one, so you can see that for a ROC it is z modulus is lesser than 1 you are getting, and this term, so that is what I can say, z modulus is lesser than, that is 1 by, I'm sorry, so this is not z modulus, this is what I can say, my 1 by 2 z inverse modulus is what I can say, lesser than 1. So these two I have got now. So what I have to do next is, I have to simplify this particular one. Which one? This I have to simplify, right? If I simplify this, I am going to get it as, that is this will, z modulus is less than 1 will remain the same, and here it is what? It is 1 by 2 divided by into 1 by z, 1 by 2, that is what I can say, into 1 by z. So that is lesser than 1. Modulus is lesser than 1. So this is 1 by z is what? Z inverse. So if you shift this to this side, so you are going to get it as over here, that is equal to your z modulus is what I can say, the greater than, that is 1 by 2 you are going to get, right? So if you get it like that, so what is that going to happen is, you have got it as z dash, that is lesser than 1, and z modulus is lesser than 1, and z modulus is greater than 1 by 2. So now my ROC will become equal to what? So my ROC will become equal to, so that is, if your z modulus is greater than 1 by 2, then what is your 1 by 2? So 1 by 2 should be lesser than z modulus, right? And it should be lesser than 1, right? So that is what you get it as. See here, you can see, I'll just tell you. So this is 1, okay? Yes. So now here, if here what I can say, if your z modulus is greater than 1 by 2, then what happens to your 1 by 2? 1 by 2 should be obviously lesser than z modulus. So that is why I take it as, that is 1 by 2, that is lesser than z modulus, that is lesser than 1. So z modulus that lies between these two regions, right? So that is why this comes to be the part of what I can say the intersection, right? I'll write this as intersection. So intersection in the sense I told you, if it is a two-sided sequence, two-sided sequence in the case of, that is properties of ROC, so that comes into picture. And what you have to do is you're supposed to what, so you're supposed to take what, that is you're supposed to take the two circles, right? Two concentric circles, so that is one circle inside another. So first what you have to construct, you have to construct an ROC. That is, this is what is the ROC that you get. So there is a circle in the Z plane, and this is real of, that is what I can say, this Z, and this is imaginary, what I can say, that is the imaginary of Z, right? This is imaginary of Z, and so therefore you can see that here you are going to write another circle, and here you are going to take, that is your 1 by 2, that is your 1 by 2. Here you are going to take, that is your 1 by 2, and here you are going to just shade it inside the, just shade it inside the circle itself, right? It is shaded inside the circle. So this is what is your ROC for this particular question. And now we haven't got the resultant yet, right? Resultant yet. So how to get the resultant yet? So that is, we have got one equation like this. So that equation is what, that is your, what I can say, that is 1 divided by 1 minus Z inverse, I'm sorry, 1 divided by 1 minus Z inverse, that is what I can say the, plus that is 1 divided by what I can say 1 minus 2 Z inverse. So if you take this, what you're going to get is, you're going to get it as Z by Z minus 1, that is plus what, 1 divided by, that is Z minus 1 by 2. I guess you got it right. So this is what you are going to get, right? So next, what is that you are going to do is, so you are going to do some simplification over here to get the resultant. So this is what is my resultant I have got. So my resultant is this only. This resultant is your x of z. But I need to get it in terms of z, right? So that is why what I am going to do is I am going to make further simplification. So right, yes. So now here, next thing what I have to do is I have to take this multiplication, that is what, your z minus 1 into, that is your z minus 1 by 2, right? Yes, z minus 1 by 2. So which is equal to what? So this z minus 1 into z minus 1 by 2, you get it as this particular resultant, right? To get this particular resultant, I have to multiply z minus 1 by z minus 1 by 2. So therefore here if I multiply with z minus 1 by 2, I get it as what? Z into, that is z minus 1 by 2, right? Yes, so 1 by 2, just a second, I'm sorry, yes, 1 by 2, that is 1 by 2, that is plus what, that is 1, here also it is z, right? Here also it is z, yes, here also it is z, I forgot to write a z, let me push it up and I'll write a z, just a second, I'm sorry, yes. So here also it is a z, right? If I am converting this into z, here also I need to get z. So this becomes what? That is z into z minus 1, because to get this particular resultant, I have to multiply z minus 1 by 2 into z minus 1. So therefore that z minus 1 I am going to multiply it over here, right? So now let me consider the next point. So that is, you got till here like this, right? So now next what you are going to do is, you are going to, yes, so now what you're going to do is, you're going to just what, multiply now. So what is multiplication? First I'll multiply, that is you z into z is z square, that is minus, I'm sorry, really sorry, so that is z minus 1 by, that z by 2, I'm sorry, it is z minus what, that is your z by 2, z minus z by 2 plus, that is your z square, that is what I can say, minus z, right? So this is divided by, that is, just a second, I'm sorry, so that is, this is z minus 1 into what? That is z minus what I can say, the 1 by 2. Right? Did you get it? Yes. So now coming on to my next step, what I have to do, I have to add z square plus z square is what? That is 2z square, right? It is 2z square. So now if I do z minus 2 minus z, so what I'm going to get, I'll just do a separate over here. So that is, if I get z minus 2 minus z, so that is what I get, which is equal to, that is what, which is equal to what? That is, you are going to get it as 2. So that is, this is z minus 2z, right? Z minus 2z, which is equal to, you are going to get it as z by 2, right? Yes. That is minus z by 2, you are going to get it as, right? So now let me write that over here. So just a second guys, I'll recheck it. So this is what I can say. Just a second, I'll check it. So see here it is what I can say. This is minus z by 2 here. Okay, I did not check it. So it is minus z by 2. So then what is going to happen is, so here this is minus z by 2. So as this is minus z by 2, you're going to get this as minus. So this is 3z by 2. That is minus 3z by 2 you're going to get. And then we are going to write that over here, right? That is 2z square, that is minus what I can say, 3z by 2. So minus 3z by 3 by 2 or 3z by 2 you can write. So that is 3 by 2z also you can write, or you can write it as 3 by 2z. So then that is divided by what I can say, the z minus 1 into z minus 1 by 2, right? Yes, z minus 1 by 2. So next I'll push it down. So yes, so then now next what I'm going to get is, I'm going to get it as, so I can say that, so that is, I can take my z out, cos z common here, because here also you're having a z and here also you're having a z. If I remove z as my commons, and I'm going to get it as, that is 2z. So z into 2z is what? 2z square, that is minus what I can say, the 3 by 2, that is what? 3 by 2, that is what I can say, 3 by 2. So that is divided by z minus 1 into z minus 1 by 2. So this is what is the resultant x of z in terms of z, right? So this is what you're going to get it, right? This is what is the resultant. So now coming back to the question now. So that is coming back to the question now. So I can I'll explain this question to you in once again. So just like I'll make a revision before closing this particular session. So let me take this question again. So see here, I'll push it back just a second. So here this is what is my given question. So what is my question? That is what? That is u minus u of minus n minus 1, that is plus half to the power of n into u of n. So here we have already learnt about what is u of minus n minus 1 as well as half to the power of n into u of n. So I've already taught this kind of problem in the last question itself, right? So see, this is n is equal to this formula. You know what is that? X of z formula that you need to write first, and then you are going to substitute this x of n to what I can say, x of n, and you are going to multiply with z to the power of minus n. So now what is that going to happen is, you are going to give the two summations for this one, that is minus u of minus n minus 1 as well as half to the power of n into u of n, and you are going to multiply z to the power of minus n to this as well as this, right? So that is what we did. We multiply z to the power of minus, you can see it is present over here, along with we provided the summation. So this kind I have already done it in the last session, Excel. So you can see that last session and you can do the same process over here. And here it is what? And here you can see that that is your what I can say, u of minus n minus 1 summation starts from, that is minus 1 to n is equal to minus infinity, right? So that is what I've written it over here. See, this is what is that, and then here you're getting it as minus is present in u, so I'm going to take this minus here also and I'm going to write it as minus z to the power of minus n. That is what is, I got it right. Here it is what, that is n is equal to 0 to infinity, because area of n is ranging from 0 to infinity, right? That is what is, I wrote it over here, this one. And then next what I did was I just shifted this summation, so that is I just took infinity to upper part and minus 1 to the lower part, so I get it as what, that is here n is equal to 1 to infinity. So for that what happens, my this z to the power of minus n will become inverse. This minus will be there as it is, you need to keep this minus outside, and here it is z to the power of minus n will become equal to z to the power of n with minus. So this is what is I did, right? And this is what will remain the same, the second part. And then here what I did was I just used the formula. Which formula? I just used which formula? So I just used the formula, that is what, so that is your summation of, that is n is equal to 1 to infinity, what I can say, the which formula, that is z alpha to the power of n formula. So that formula if I use, I get that is alpha divided by 1 minus alpha, and that's what I got it over here. And then here this one, what is that I used formula is, that is n is equal to 0 to infinity alpha to the power of n formula I made use of, right? That was I made use of, and I got this resultant over here. And then what I did was I just took this in terms of z transform, because here also it was there in terms of z transform, but here it was there in terms of z, so I had to take it in terms of z transform, so I got this resultant, right? So now what is that going to happen is, I got to know that for the terms to convert, it should be lesser than minus 1. So therefore now by this equation what I saw that, so your z modulus is lesser than 1, as here it is only 1, so this is z modulus is lesser than 1, and here it is 1 by 2, that is z to the power of minus 1, this one. So that is 1 by 2, that is z to the power of minus 1 is what, 1 by 2 z to the power of minus 1, that is equal to what I can say, the lesser than minus 1, right? So yes, so if I simplify this particular, so I got like this, that is z to modulus is, that is what I can say, less, that is greater than 1 by 2, and this is z modulus is lesser than 1 I got. So what is going to happen is, so what is that going to happen is, so if your z modulus is greater than 1 by 2, your 1 by 2 should be obviously what I can say, the lesser than z modulus, right? So therefore that is what we consider over here, and we wrote that your 1 by 2 is lesser than z modulus, and this z modulus is lesser than 1 as given here. So this is what is with resulted in intersection. And so therefore what did we do, we just took the what I can say, the ROC of this particular, so that is it is a ROC of that particular, that is what I can say here, two concentric circles, right? In the properties of ROC, if you check with respect to the properties of ROC, so you can see in the case of properties of ROC that if your x of n is a two-sided sequence, then ROC is a concentric ring in the z plane. That is, this ROC was a two-sided sequence, so therefore I can say that what, there is a concentric circle, that is ring inside the z plane, and so therefore that is what I have written over here. And what you have to do is, you have to draw like this one and a concentric circle, and you are going to mark a point here stating 1 by 2. So that point is not marked up, just a second, so that point is not marked up over here, I'll make it bigger. Yes, so see here, I'll make it bigger and I'll mark it in a clear manner. So here you need to take a point. Where you need to take a point? You need to take a point where, that is somewhere here. So here you need to take a point somewhere, and you are going to write it as, that is 1 by 2. Right, 1 by 2 you are going to write it as, and then you need to draw concentric circle over there, right? So this is what is we required. And then now what did we do next is, So what did we do next is here, so we just took what, that is we just took the, what I can say, the this particular, that is this particular equation what we got over here, this one, the same thing we took it over here, and we just got it in terms of z, that is the z resultant is what, so the z resultant is given by this particular. So if you simplify this, you are going to get the z resultant as, that is this one, that is what I can say, the this one, that is what I can say, the z minus z into 2z minus 3 by 2, that is divided by z minus 1 into z minus 1 by 2. This is what is we got it, right? So this is what is for this particular problem. And one more thing I forgot, so I'm going to showcase to you here. See, I'll erase this part first before showcasing that. Yes. So then next what I have to showcase is, so here this here you got what you got, that is summation of n is equal to 0 to infinity, that is what I can say here, half to the power of n, I'm sorry, really sorry. Here half to the power of, what I can say, n into z to the power of minus n. So now what I have to do? I have to remove my n, right? I have to remove n. So what is removing n as power, right? We have done it in the last session also, right? If I remove n outside as a power, then I get it as, that is 1 by 2 into z to the power of minus 1, that is whole to the power of n. So you need to write that step. So this one, if you take n outside, so you're going to get it like this, and along with that you have to add plus this particular, what is that, this one, which one, that is what I can say, the summation of infinity to n is equal to 1 to infinity. So that is what I can say, z to the power of n plus this particular. First you need to write this one, and then you are going to add this one, right? So this step I missed it, so you have to write the step, and this is what is for this particular problem. And I guess you understood this. All the procedures are what we have done in the last problem itself, that is what I shared it today morning. The same procedure you are going to follow, but what is the matter is the question is different, that's it. The procedure whatever we have told, the same procedure, right? Here also see, this procedure we have already done it in the last session, and this procedure also we have done it, and this multiplication, this procedure also we have done it. That is what procedure, that is the procedure with respect to give providing the summation, proper summation, that is your u of minus n minus 1, what was the signal that you got, for that signal you provided the summation, right? Yes, summation over here. And then what did you do, this n, taking this n as a power also we did in the last problem, and before last also we have done this procedures, right? And then we have got this kinds of, we have applied the formula, that is what formula, the formula is what, a formula is what I can say, that is summation of, you have two formulas over here. So please do remember those two formulas. I am going to write it over here. So please to remember those two formulas, that is the two formulas are summation of n is equal to 0 to infinity, that is what I can say here, alpha to the power of n, which is equal to alpha divided by 1 minus alpha, and one more I'm sorry, this is one, I'm sorry, this is one formula, just a second, this is one. And for summation of, that is what I can say, n is equal to 0 to infinity, that is alpha to the power of n, which is equal to what, that is 1 divided by 1 minus alpha. So these formulas you have to remember for your particular question, right? Not only for particular questions, for all the questions, right? So now let me I've already told you the procedures and steps how to do, so please do jot down that procedures and the, what I can say, the procedures, and you are going to follow the same procedure. Just learn that procedure, what he has done. In the first procedure he has taken the formula, in the second procedure he has applied x of n to that particular formula. Then what did he do, he just multiplied z of n to, that is the two given question, that is you have a your addition of two things, right? That is minus u of minus n minus 1 and half to the power of n into u of n. So for both of that he provided the summation, along with he multiplied with z to the power of minus n. So then what happened, so then we got, what what did we do? So we have said u of n present there, so we just change the summation according to u of n what is given in the question. Then next you are going to what? You are going to do what? That is, you are going to remove the n as power, and you are going to get something like 1 by 2 into z to the power of minus 1 whole to the power of n. Then you are going to apply the formula, and then you are going to get the resultant, and after that you are going to do the ROC. So it is like you are going to note down the steps like that, and you are going to follow the same for the each and every problems without fail. There are some kinds of problem in each and every problem use the same, but there are some kinds of problem wherein the procedure will be somewhat different. So I'll also showcase that problems in the next classes, and thank you.